Welcome to the sixth experiment in System Software and Compiler Lab. We have single pass assembler for SIC. Okay, so what this experiment is supposed to do is that it simulates the concept of a single pass assembler for simplified instructional computer. Okay, so basically generates an object program. Okay, so now there is an algorithm for doing this. Okay, you can see the algorithm. You read the input file. The input has a opcode start. You find if there's any operand field after start and initialize the counter. Okay, the location counter to the operand value. Otherwise, if there is no value in the operand field, then location counter is set to 0. Okay, and you can see that each of this, so if there's an opcode, it has in the text file, you increment the location counter by 3. If the opcode is word, increment it by 3. If it's byte, increment by 1. If it's reserved word, you integer equivalent of the operand value into 3. Okay, so we have a sample input and output. So I wrote this program using Python. Okay, so we have our Python code here. Okay, so I'm going to go ahead and explain this code pretty quick. Okay, so we have what they call optab.text and pgm.text. Okay, like from the equation is quite clear that our input files includes the program, the opcode table and the symbol table. Okay, and the output file is this. Okay, so I put our input file into this is where the program is saved in pgm.text. The opcode table is saved in optab.text. Okay, so you can see that. So what this does is that it opens the program.text and read the lines and put them in I, and op opens the opcode table optab.text, the text. It reads the lines and moves them to op. Okay, then output opens a file. It creates a file output.txt. Okay, so then our optab is read. Okay, so for line in op, that's for line in the optab, you split the line and you update. Okay, and for line in I, if there starts, then according to our algorithm, if start is in the line, then x is equal to the location counter will be equal to the next value, the next operand after start. Okay, and that's what we do. Okay, we are using append. We append, and then each time an operand is read, you increase by 3. X plus is equal to 3. Okay, increment by 3, increment location counter by 3. Okay, and using this function, you convert it to hexadecimal value. Okay, using this str hex length into 3, you convert it into hexadecimal value. So when you're writing, your output will be like output.write. You have h, which represents head. Okay, then after the head, you have the starting address. After starting address, you have the length of the file. Okay, and then the text gets the starting address of that particular text, the length. Okay, and then the proper object code. Okay, and then the end file comes with it starting address, and then it closes. Okay, so that's basically this program. So if I run this program now, dot slash okay, so if I run this program, you can see that output.text is created. Okay, so if you check output.txt, you can see that the object program has been created. So this HTML is the header file, copy name of the program, starting address, length. Okay, and then the text file, you have name of the program, length of this particular program. You have each of them is divided by 001006231009. Okay, and then you have the end file with the starting address 1000. Okay, so that's basically the simulation of an SIC assembler. Thank you for joining.